Okay, so we were here that where security can be very complex for these modern days applications, or how the way we are developing the modern days application. Another use case is like this: when a client sends a request to the sends a request to the server, or in this case of some microservices, then the client details needs to be verified. Just the things we discussed in OpenID or auth or OpenAuth. So this is something that to be performed using the microservices. And it may happen that for each and every service, you have to authenticate and authorize the client. Now, to do this, developer might use the same code for each and every service. And don't you think that relying on the specific code reduces the flexibility of the microservices? It definitely does, right? So this is another major problem when you are using the same code, or you're reusing the same code for authorizing as a authorization logic, even though you know that you are running different microservices which will probably should have different authorization logic, but it is not happening all the cases. Okay. And another thing is the third-party applications. Many of these microservices we are developing that uses third-party applications. Security in those third-party application is also very much complex, because that is also like maintaining the list of third party is also a distributed job, and it becomes a problem. Okay. So these are different use cases where security is becoming complex. In the previous slide, we have seen how security can be managed in a better way for microservices, but that is not the end. There are few cases where security is also becoming very complex. And more services equals to more complexity, and more complexity means more breach of security, more vulnerabilities, and more weaknesses, more threats. And because you have to connect these microservices, it is just if it is just one microservice is fine, but if there are 10,000 microservices running for one single web application, in that case it's a problem. That means 10,000 different connections to be made between the microservices. That means 10,000 times we are exposing the connection, we are exposing the data traveling through where. That is the problem with the security. So more services means more complexity, and more complexity means more threat. And imagine a system which is running on multi-cloud. That means few of the microservices are running on AWS, few of them are running on Azure, few of them are running on GCP. In that case, connection between the microservices is much more complex. One microservice needs to connect to another cloud provider, another microservice, another everything is different. So that is another problem. Identity in that case, identity and access control, how you can manage, you have to replicate the similar identity management or similar kind of access control, which is very difficult, because AWS access control is a different format, or in the different configuration. GCP access control is another different configuration. So that is really difficult. Data and message integrity is another problem, because AWS might be storing the data in a format. GCP is storing it in a different format. Some of the microservices storing it in say MongoDB. Another one is using a graph database. In that case, it's a problem. How you can interoperate this data. And beyond the myth, most of the cases, the people who are doing this, they will say DevOps, DevSecOps, or what we are the developers. We always think, hey, these are the new technology. That means security is already taken care of. Many of the cases we just think, okay, this is secure, inherently secure. Whatever we do, it will be secure. That's many people believe. Like MQTT. MQTT is a secure protocol, everybody says. Many people use MQTT or Kafka and thinks that okay, this is the state of the art technology, and in their product details or in their product brochure they have told that this is inherently secure. That means I don't need to care about the security. Secondly, many people think that I am using AWS, so if there is any security breach, Amazon will be responsible or GCP will be responsible. And third biggest problem, not third, in fact, the most problem, the biggest problem, I should say, is we are chasing a speed. We are chasing crazy deadlines. Speed is everything here. The moment we are thinking about speed, usability or usability comes first. At least we have to make the product ready. Then we have to think about the security. If I think about the security in the beginning, it will slow me down. So no, well, let us first to create the prototype, and that approach is itself problematic. It doesn't take care of the security inherently. It doesn't take care of the security in their design. Okay. And just take like if you ask your business leader, hey, I have a product and should I add a new feature or should I spend the time on security? Of course, the answer will be, hey, go and add the new feature. So this trade-off is always there. Whether we are going to add a new feature, we have limited resource. Using that resource, whether we are going to add a new feature or we are going to add security. This trade-off is always there, and from the business perspective, business will always focus on the features. It will always focus on the usability or functionality or those things because they have to run the business unless and until they get screwed up by some security breach or data breach. Then the scenario is completely different. And when it happens, then rest of the companies just think, hey, we have to do security, we have to do security. A lot of security training, security seminars, all these things happen. People spend a lot of money to buy few security tools, and then everything. Then again, during the release of the release cycle, everything goes into the training. So nobody cares about the security the way they care about the functionality or the feature of the product. So looking into the valley, we have to secure everything using defense in depth mechanism. That means there will be multiple way to like if there are multiple layer of security, we have to use all of them. Not one security should not be in one place. Just as an example, if you remember in our first class, we have seen buffer overflow exploits, right? And in the buffer overflow exploit, we have seen that how not comparing or not checking the array bound, how it can be attacked or how it can be manipulated, right? And there are a lot of different ways to fight that problem. The best way is in the kernel level. The kernel will not allow you to do any buffer flow or any buffer overflow. Like ALSR people use, DEP is used. So that is randomize the address, all these things happen so that even though if you want to run a particular code sitting inside your data segment or code segment, it will not find that, because every time the code is running, it is a new memory location it is jumping to, new address is getting allocated. So all these different mechanisms are there, like ALSR, DP. During the compile also, you can put lot of flags so that this randomize this buffer overflow will not happen. Canopy and all these things can be implemented there. But does that mean we will keep this weakness in our code? Answer is no. We should try to fix that. This is called depth, defense in depth. That means in every layer, we should fix the security flaw so that the overall system will always be secure. Even if one layer is compromised, the other layer will keep the defense on. We have to scan the dependencies. That means all the third-party component we are using. We have to keep a very close eye on those third-party third-party libraries or third-party modules that we are using. And the communication that is happening between the microservices should be HTTPS or encrypted. Many of the cases, in fact, I have seen 50 to 60% cases, the microservices, the developers don't want to use HTTPS for the microservices. And one of the myth is that HTTPS might slow the communication down, but it does not actually. Now it is quite faster. So use HTTPS. If you are using MQTT, then use the encryption of like in that case IPsec or something, some other encapsulation you should use for sending the data from one microservice to another microservice. Access control and identity token is a very big problem for the microservice. This was not a problem for monolithic structure, but when we are going into the microservices, use access and identity tokens are very big problems, and we have to really be very careful to make these things secure. And encryption and protect secret is another problem, because every single party, like just imagine every single microservice is creating their own public and private key. That means every single microservice is generating two big prime numbers, then they multiply it, and then they do all these RSA cryptographic stuffs and all that, which is very power consuming and computation consuming stuffs. And everywhere we are doing that means it is using a lot of system resource. Imagine if you would have a monolithic system, one pair of public and private keys enough. Now, if there are 10,000 microservices, we are breaking that monolithic one application into 10,000 services. That means 10,000 pair of public private keys are required. Okay. And we really cannot, like, even if we cannot make a defense mechanism for all the microservices, at least we should try to slow down the attackers, because since these microservices are interlinked, one microservice is compromised means its token, identity token or authorization token is compromised. That means everything will fall down like just like a domino effect. Okay. Use Docker in rootless mode. This is another, I would say, commandant. You must use Docker in the rootless mode, because most of the times by default Docker runs in as a root. What is the problem? Anybody can anybody tell what is the problem if I run Docker as a root? What would be the problem?
Privilege escalation might happen if it gets compromised.
How the privilege escalation? How it would happen?
Because Docker, that process is having root permission, right?
Yes.
If that get compromised, it can access anything. Root is super user, right?
That's exactly correct. So what we are discussing here, there is a nice term for this thing. It's not root escalation or privilege escalation. The term is called VM escape or Docker escape. I'm just giving a small example here. Close terminal. So this is my Linux machine. If you can see, I'm in /etc. And if I want to create a new
Not visible actually.
it's
we
not.
can see only the desktop.
Sorry.
We can see only the desktop.
Okay. In that case, am I sharing a wrong screen? Now can you see it? No, it's still presenting share. Now can you see it? Now can you see it in screen?
Yes.
Oh, sorry, I was actually on the wrong screen then. Okay. if I do a touch or and I want to create a new file. Touch means create a new file. Okay. It says permission denied. So I do not have permission to do anything in the slash etc. Or if I want to see vi pass wd, pass wd is okay. Pass wd is for me vi shadow.
Shadow.
Shadow I cannot see because
User doesn't have read permission also.
it should not have a. I cannot see. This cat shadow. I do not have a permission to read it. Now let us do one thing. I'm running a Docker, any Docker, and then it is in detach mode. I'm just mounting the root folder, and then let's see CentOS 7. So now I am inside the Docker. This is the Docker running, and inside the Docker, I've been root. Now let us see. Host I have mounted. If you see there is all the folders. Now I just go to slash etc. All these folders are there. Now I am just doing touch ABC. It didn't ask for my permission, right? I'm just opening another. This is the one. See, ABC should be there. Mhm. Okay, here I come. Do you see the ABC? Where I have been? PWD. Oh no, I want to be here. Now I am doing the touch ABC. I guess now it will come here. This is here.
Yes.
So using the Docker, I could easily created a file ABC in slash etc where I did not have a permission. If I just want to do that from here, permission denied. Or I can open the shadow file. Yes, I can change it as well. But here I cannot open the shadow file. See. So this is a problem. You understood it, right? Everybody understood what we just saw?
Yes.
So this is
Yeah.
called Docker escape. So this is the reason we should always be careful while running a Docker. It should be in rootless mode. We should only mount those files or those folders or directories we really want to, not everything. So these things, but while writing the codes, developer hardly maintain these things, because most of the cases developer thinks, okay, today I need this file, for this I am doing one mounting. The next folder again I have to do another mounting. Let's mount the entire thing. Why the problem? What is the problem? Let's mount everything and we can access everything. Or sometimes they think, okay, if I don't run root every time, I have to run sudo. Many of the cases, many of my program calls will fail because it is not running as root. So it will ask for password. All these things happen, and then writing the test case will be difficult. At the end of the day, it is DevOps, so I have to write the test cases. So that will be difficult for me. So that's why people usually love to run it as root. In that case, I don't have any tension. I have any script will work seamlessly for that. No script will be stopped, or it will ask for a password prompt or anything. We always want to bypass that thing, and that's why we run the Docker as root. But that is not a very good idea to do. Okay. And the time-based security means just use when just provide access to those service or data or file when it is required. When it is not required, remove that. It is nothing called a perpetual permission. So always use something which is a time-based or the temporal permissions, right? And also there are a lot of tools, security scanning tools for Dockers and Kubernetes, how they are configured, whether they have any vulnerabilities. There are a lot of things. So use them. And also what you are using as a Docker image, that image might be also for vulnerable one. There might be a lot of vulnerabilities in that Docker image, because that is not what we are developing, or the developers are not developing there directly. They are simply taking that one, right? So that's why always use the official image. At least if you use the official image, if anything goes wrong and if it has any vulnerability, it will be reported widely. Please do not take these do not use any unofficial image of any platform or any OS or any other Docker. Always try to use the official one if it is available. If it is not, at least use something which is signed, or you have checked the check the hash SHA-2, SHA-512 or MD5, whatever hash you like. At least you should check that one. Okay. And your cluster and cloud both are another part of the security, another part of the system. You should know that what is your contract with the cloud provider, whether they are going to take any responsibility for the security, what kind of security support are they going to give. Most of the cases when you are using a platform, the platform level security is with the cloud providers. Like if you are using a SaaS, then operating system related security will be with the cloud providers. But your code is your responsibility. Your applications, your microservices are your responsibility. And at the end of the day, when you are delivering it to the customers, do not know where you have put your code, from where you are running, whether you are using AWS or GCP or whatever it is. They know it is your product, your responsibility. The first lawsuit will happen against you only, not against AWS, just because you are using AWS there. And most of the cases, the security liabilities are also mentioned in the service level agreements. With that, we know that there are a lot of tools, GitHub, Bitbuckets, GitLab, all these things we use for code as a code repository. We use Jupyter or other Jupyter, Eclipse, all these things for developing it as a integrated IDE and kind of remote development stuff. We use WSGI server, we use Flask for web server, we use a lot of different tools. And all these different tools means the moment we are using different tools for our code, that means it is creating new attack surfaces. How about I have a perfectly secure software, but I have kept it in GitLab, and the GitLab is repository is compromised. Anybody can come and add some malicious lines of code in my code. Then it is problematic, right? So GitLab is also part of the system. It is part of your development system, but there might be attack. It might be another attack surface. There might be attack through GitLab. Somebody have an access to GitLab. they can change the code or they can read the code. That is not right. That will somehow affect my product, what I am developing. I'm using a Flask or Django as a web server, and if there is any vulnerability coming from Flask or Django, then that is affecting my system, right? So all these things are problematic. All these things happen, and we have to be really careful about these things. Already covered, and I don't think we need to go into details about how the classic development used to work, how this development right now happening. DevOps has a beautiful name used by Amazon. It used to call it two pizza team. That means the entire team size should be so small that two pizza would be enough to feed the entire team. If you need to order more than two pizza for a team lunch, that means you are having a bigger team. Reduce the size of the team. And every team means like every team should be responsible for one microservice, at least one microservice. And responsible means it's full ownership. Okay. Later, in almost 8 years later, in 2009, this DevOps term came in, and the two visa team was replaced by DevOps, and then it started in Amazon, but later many other companies has adopted this DevOps thing, and now I think it is almost a de facto software development philosophy that we are using in the industry. Okay. This is an Amazon, in the Amazon web applications. All these vertex of this looks like a mushroom, right? And all these vertex are actually a one microservices. So there are, if all the microservices are connected there together, it will look like this. And connection between the vertexes are actually the message, like communication happening between the microservices. This is the Netflix mushroom for the microservices. And all putting together, like if one microservice, I just take only one single vertex from this or one single dot from this mushroom, it would look like this. There are a lot of different stuffs happening inside this vertex. So that's how the Amazon web page, it looks so simple. We every day use this, not every day, but very frequently use this web page. But this kind of situations are happening there. So many different microservices are running. Doing all this, I think we all are quite familiar with all these things, how code commit, code pipeline, how the CI/CD pipeline works and code deploy is happening. So this is part of the DevOps. There is one good website I'd suggest that because there are so many different tools, I think thousands of different tools for our different areas of the DevOps development. So it's very difficult to track which to enter a corporate address. Okay. So it's very difficult to track that which tool does what. How many, so many, there are at least 10,000, 20,000 different tools are there in the market, and it's very difficult to understand that which tool does what. So it is kind of a periodic table of the DevOps tools. It's very nicely they have used it, and different color means where exactly they are using. So in the deployment side, these are the tools that are used. And in the security side, you can see so many. This is the security zone on this periodic table, and these are the different security tools we use for our DevOps, like WASP, ZAP, Digital AI, App Protect, Aqua Security. Sonatype, Nexus, I have not used it. HashiCorp Vault, this is a very like widely used vault, or where you can save your passwords and all the sensitive data you should use in a vault, and HashiCorp Vault is widely used. SonarQube, what we used. Similarly to like Synopsys, Black Duck, Checkmarx, SAST or Fortify, all these things are there. So these are the security tools that are widely used for DevOps. But other tools, we probably always lose track that what exactly, if somebody says JFrog, it's very difficult for us to what exactly JFrog does. So it says it's a package management. JFrog is here. It's a blue. It's a package management. And you can actually go detail into that what exactly it is, how it does and all. For that, I think the link is not working in the PDF. But yes, there was a link. You can actually open this thing. And these are the what are open source, what are free, all these things are there. So this is a very nice. This is a very nice thing. When I usually do a threat model or I'm getting involved with any of the architectural review, every time I do that, every time I learn at least 4 or 5 new tools or new technologies in the discussion every day, in fact. So it's very difficult for me to keep the track. And I usually carry a printout of this periodic table, so that at least when somebody says I don't need to know what exactly that tool does, but I should know that where exactly it falls to. And that's why I can actually keep I can connect in that discussion. Otherwise, it will be very difficult for me to find out which tool does what. Okay, so this is a nice thing, and I usually use it here. Okay, and if you like, this is a slide where so many different tools for so many different things. It's the first of all, it is crazily so many different tools because so many people are using developing all these tools and using DevOps. It's very difficult. Okay, and now coming to that, now we have databases, we have cloud environment, we have CI tools, we have collaboration tools, we have message brokers, we have containers, file systems, search technologies, all these things are there. And we need to know how we can secure each of these components from the ecosystem. So far, we are looking into as a holistic view, as a forest. Now we are going into the trees. How exactly inside a microservice we can make everything everything secure. In database, MySQL cluster, Oracle DB, these are used. Non-relational database, MongoDB, Cassandra, these things are used. And we need to know how to secure these database, how to make a secure access for this database. So whatever product we are using, we should go to the security documentation page, and we should make the we should use the secured configuration of that, because most of the cases default configuration is not the secure configuration. At least for MongoDB, yes, the secure default configuration is not the secure configuration. You have to do a lot of other configuration just to make it secure. But I don't think people do that. Most of the people do use just out of the box flavor of MongoDB or any other database. SQL injection attack happens, no SQL injection attack happens. Biggest threat is ransomware. I don't need to attack, I need to read the data. I just can simply encrypt your data. Everything is gone. Okay. And MongoDB running internally is a web app with web app exposed. That is a problem. Anybody inside that network can access the MongoDB web app. It is accessible internally. It is also sometimes, if some people want to access it from some external network, especially when there are multiple cloud platform involved. In that case, we have to get it exposed, or there are multiple VLAN involved. We usually expose the MongoDB web app or MongoDB port outside the network. And that means it is a publicly exposed. And that means it is just a matter of time. Some attacker will find out this port and exploit that. Okay. And for MySQL, one problem is it is mostly the host name based authentication. That is not good for MySQL, any SQL database. But nowadays there are a lot of other ways. But default one is always bound to the host name. It is a host name based authentication. That is not good. Okay. When we use Redis is nothing but a data store, a cache data store. So it exposes all interfaces. That is a very big problem. It has a lot of configuration flaws. Redis has, many people use Redis for caching the data to make it faster, but that means it has access to all the data, and this is not inherently secure. And Redis doesn't have any authentication. Like it by default, it does not provide any authentication. You just install a Redis, it will work without any authentication, and it will start accessing all your data. When you are using AWS, there are a lot of different component we use, like Route 53 as a network router, as a network, for IAM for your access control, S3 for storing data, EC2 for as a platform or just as a virtual machine, Lambda as a serverless functions. All these things we use in AWS. And most of the cases, your code is your responsibility. That's what is AWS says. So if there is a vulnerability in your code, for doesn't matter where it came from, if it is there in your code, that means it is your responsibility. AWS is not going, Amazon is not going to take any responsibilities. That similar to that, Azure Stack has also many different services running. Google has that. And AWS attack vectors, one like what we got in recent past is the leaked credential. There are managed service misconfiguration. Mainly AWS misconfiguration is a very big problem. There are so many different services AWS provides, so many different components it has. Connecting the components will lead us to a very complex configuration file, and that leads us to a misconfiguration. So we need to be very careful about that. S3 bucket is not inherently secure because access control mechanism used here is ACL, which is not the right thing. It is an access control list. It's not even a matrix. Bucket policies and IAM policies might be conflicting. In that case, IAM policies presides will get more precedence. Okay, and default ACL gives full access to the creator, which is not good. The developer is not always the user. Even though you just imagine you are using S3 bucket and put some customer data, and then it goes to the then customer starts using it in their production, but developer still has full access to that system, which is not good. Okay. So anonymous access is another problem. Many times we turn on the anonymous access where it is very difficult for us to log who did what. Lambda function, there is a very nice article on how you can exploit the Lambda function and things. So after that, AWS has come up how you can secure the AWS Lambda function, and please follow these things. And there is a white paper on securing the Lambda functions. So if you are using Lambda function, you should use that. CI tools like Jenkins, TeamCity, Bamboo, GitLab, all these things we are using. But again, the configuration issues, especially when we are creating the CI/CD pipeline, we have to be very careful. There is no CSRF token installed most of the cases. One more big problem is the credentials are not always encrypted, stored as an encrypted format or stored as hash. This is the location where I think it is, yeah, this is what I think GitLab does. GitLab has a default location to keep all the credential in plain text. If you do not secure this location, then you are in trouble. Okay, so these are the things that happens with us with the CI/CD tool. This is a CV that is with Jenkins. This is a CV with, I think this is also with Jenkins. And this is a very high severity issues that affected thousands and thousands of software which used Jenkins for their development environment. And Git, SVN, Parforce, these things we use. Again, first of all, the access control is a problem. For that, we need to be really careful for the access control. If you are using GitLab in a machine, just if you are interested, you can just go to this file. GitLab is usually encrypted, but sometimes it can be plain text also, and it contains a lot of interesting information about the users and the credentials. So this is one of the attack surface. It's a very interesting one. This is an SVN related vulnerability. It's an 8.6 high vulnerability. We use message broker, RabbitMQ, Kafka, all these things, and they might have their own vulnerabilities. There is the access control can be changed. That means you can use other access control here, which is not good always if you are not careful of how you are doing that. And anybody can access these things as a guest user from localhost. Containers, we know what containers are, mostly Docker. And we just saw that how container escaping can be done. So escaping and privilege escalation is a big problem. We saw that. We have seen the patching and update. This is another very important thing. Very like I have not seen anybody who keep on patching the Dockers that works at least for their microservices. I am creating something, I have run it in a Docker and the Docker it is running. After that, nobody patches the Dockers. These are just simply use the same image again and again. But imagine that Docker image, that image might have a very big vulnerability. And in that case, your entire system might be vulnerable. Okay. There are a few tools that does that check, like Clear. Clear is a free tool. Tenable, Twister, Qualys. These are the paying tool. Okay. So these are the security commandants that how you can do that. Use copy instead of add. Oh, these are more for the developer. If you are not developer, then I don't think this will. This is kind of a commandants for the developers. It is this is I usually create this kind of commandants and share it with our developers. So for developing, he should know these things. That's the idea here. Okay, and so in just few sentences, for if I want to explain that what we have just learned here is nothing is inherently secured. Nothing is inherently secured. We have to take care of the security. We need to know how we are doing that. We need to focus on the configuration side. All these things we need to do. Otherwise, we will be in trouble. Okay. And always read the documentation and security configuration guide. It is always there. Any tool you are using, any modern tool, it has a security configuration guide. You use that, you read that, and that is so. As a security expert, if anything happens or anybody asks that how to make it secure, the easiest thing is to do is find out the security configuration guide, which will be available in their website, and then you are in a position to provide GANs. Okay. And threat model. This is very important. Doing threat model is not as easy as we are doing for just a web application or just a small software. It is now we have so many different trust boundaries. And we have to really take care of all those trust boundaries, how we can work on those threat models. Okay. And most of the cases, there is no hard and fast rule for doing the threat model. Just think like an attacker would think and do the threat model, find the attack surfaces. Do DevSecOps, not just DevOps. DevSecOps means implement the security log quality gets inside in the pipeline, in the CI/CD pipeline. There are a lot of other things. We are probably going to have more exciting years ahead when we are into this industry. We will see a lot of other changes. The way we see these changes, it is really revolution. And I believe in the coming years, the coming few years, we'll see more and more such revolutions in this field. The way we are entirely change the philosophy of creating new softwares. It's amazing. And now its softwares are not on-prem softwares. Most of the cases they are applications. And the way it is happening, it's mind-blowing. Probably we have very good, exciting times, and more technologies come, more tools come. There will be more security loopholes. There will be more attack surfaces, And if there are more security loopholes and more attack surfaces, congratulations, all our job are secure. That's all from here. Any question? Anything that you want me to go in little depth? Because I have finished it in a very superficial way. I didn't go to depth on any of this. Just as a very overall picture, I wanted to provide you. If you want anything, if you have any question, please feel free to ask. Or if anything you want to discuss, or if you have anything to add here for me and for others, if you have any hands-on experience, please share that here.
Not as of now.
Okay. And who work on DevOps? I think somebody said, I think Vijay Raj, right? You are working on DevOps, DevSecOps, right?
Yeah, I'm managing the team, work on the DevOps, DevSecOps.
Okay. Now I think in this lecture we have covered a lot of things. Probably many of the things like now you have a mind map that what does what as a manager.
Yes, yes, for sure. Actually,
Okay. And do
gives
you
a
want
good.
to share any experience that you have in DevSecOps or something that is very interesting for us?
Uh, no, I'm getting now. Getting in specific.
Okay, sure. Anybody else have anything to add here?
Hi, sorry, Soumya.
Sure, please tell.
Regards to that Dockers, you are saying about how to secure Docker, or there was some tool called Claire and other stuff. If
Yes,
you just open that slide, uh,
sure. I think here.
I think next one there was related to only specially Docker.
Yes, these are actually okay. I skip these things.
Yeah, that one. This backside.
This one.
Uh, yeah, this one. Tools to check Docker's configuration. The Claire and this Qualis you are saying as that vulnerability management one only you are saying, or
Yeah, Qualys and Tenable both are vulnerability management tools for it works for any places, and they have some specific version or specific flavor that works only on the Dockers and Kubernetes. I think this is a better slide for you to answer your question. So this is a tool creates a service mesh and default mutual TLS between the microservices. This is one tool that we use. You have Docker file configuration, right? So for that, Hadolint is a very nice tool. It provides you insight on the Docker file, how you are writing the Docker file, how you are writing the whether all the configurations are okay. The requirement of the Docker file in the requirement section, if you are using any vulnerable image, all these things it does. And this is a thing. And
the only
yeah,
thing is suppose whether any of organization will allow to install this Hadolint, or this is open source, or how it is.
these are in this page, whatever we have is open source. And Clear is a vulnerability scanning. I think now they have changed the name for Clear. It is something new name has come. I think you can just search in the Google. So Clear was a very
Okay.
famous vulnerability scanning tool. It is also free. It is open source and free. And apart from that, for other vulnerability scanning tool, there is something called there is Tenable Docker is there. I guess Tenable Docker. So that is a different version of Tenable. In general, we use Tenable for network vulnerability scanning, right? Or any
Yeah.
host vulnerability scanning and the network scanning, we use Tenable. And Tenable has a specific flavor for named Tenable Docker. And that is another paid version. You have to, like, people need to pay a more for if they want to use that particular feature, the Docker scanning feature. In that case, they've you can get another vulnerability scanning for the Dockers running inside a host. And same is true for Qualys as well. Qualys also has some capability of doing the Docker scan, and that is, I think, that is also a separately payable version. It is apart from the other Qualys platform. You have to pay separately for the Qualys platform, and on the top of that, if you want to use the it's yeah if you want to the vulnerability scanning for the Docker, its capability for the Docker scanning, then you have to pay more. That's how it works.
Okay.
And
Okay.
so many of the companies usually pay for these tools, at least for these kind of vulnerability scanning tools. Okay. But here on this page, whatever tools I have put, these are open source. You can feel with under MIT license.
Okay, Soumya. Thank you.
Okay. Anything else? I just purposefully skipped all these things because this will be, I think, going to this much of detail will not make much sense here. Okay, then we can move to the next part of this, in fact, last part of this module, which is IoT security. Should we move to that?
Yeah, yes.
Sure,
Yes.
sure.
Yeah.
So far what we have discussed, like, is it interesting, the last section, that is the modern application stack, what I showed, that is probably more into what you probably will see in the industry if we were not getting the hit right now. I'm sure in the coming 1 or 2, 3 years, you will feel that these things are really important, and so many different things people will. In fact, I'm telling my experience when I go to a meeting, usually the design review meeting or the architecture review meeting. Most of the cases, initially my problem was like this. These guys used to speak in such a technical jargon, so many different tools they used to talk, and I really couldn't find that where I should start reading. Where like I know that okay, the architecture that I have studied in my college or the architecture that I have been studying in my job, it is changing rapidly. And now new teams have come, new teams are doing the software development in a different way. The architecture is changing, and it was really a difficult time for me to understand or start with where I can. People are coming to me, hey, this is what I am doing, and now tell me how to do the security. Now, first of all, I really could not understand the architecture. That's why I had to go to the back. I had to go to the basic, and I had to start understanding these things. Though that is not part of my job. I am not supposed to learn what Docker is, or I'm not supposed to learn what how to run a Docker commands and all these things. But what I felt, without knowing, without going into the details of these things, or without doing hands-on these, it's very difficult for me to understand that what these guys are doing or how the developers are developing all these things. So that's why I purposefully created some projects for me. I just did some hands-on, and then I understood this is how the security works. So my suggestion to all of you, if you struggle with any new technology or any new tool, the best way to do, at least the way I have felt, the best way to do is that install in that on your own machine. Try to just run some Hello World program, even that also works, or something, some better project. Just take a very small project, try to do that hands-on, and then you will understand how this thing works. And since you already have a security background, and in these 2 years, you are kind of grilled with all these security technologies and security stuffs, the moment you are doing it the hands-on, the things will come. Okay, this is where the security might be get compromised. This is where I can make it more secure. This is where the developer might make a mistake in terms of security. So that's my suggestion. If you are stuck with any technology, it's better to just install it in your machine and try to do something. That's the best way to do. That's my suggestion, or that's my way of doing it. I'm not sure whether that will work for everybody or that is the best, but yeah, that works for me very conveniently. Okay, I'm speaking for all non-stop for almost last for 50 minutes, I guess. I'm just taking 3 minutes break. Sorry for that. I just need to have some water and some. I just need to
We'll
have.
take five minutes break and come. No problem.
Okay, 5 minutes break. Fine, 5 minutes break and come.
Okay.
And prepare. We are going to have a GD very soon. Like in the beginning of this thing, we'll have a GD and then we'll go to this IoT ecosystems. Okay.
Okay. Okay.